Hello there, and welcome to Theories Before Sleep. I'm so glad you're here. Maybe it's been a long day, your thoughts still spinning through hours that felt too long or too short. Perhaps you're wondering about time itself, how it moves, why it flows, what it means. Or maybe you're simply seeking something peaceful to carry you into sleep. Tonight's journey is for you. You don't need to do anything but rest. Let your breath slow, your thoughts soften, and your body grow light as we explore together. We're going to explore 100 theories about cosmic time, not in a rush, but slowly, gently. From the nature of moments to the possibility of eternity, each theory a quiet doorway into wonder. Some will feel familiar, others strange. All are presented to help you drift peacefully towards sleep, carried by questions that have no urgent answers. If these explorations help you unwind, consider liking and subscribing. It helps others find their way here too, one sleepy soul at a time. Now, let's begin. The first theory is waiting, patient and quiet. Time might not actually flow. Time might not flow at all, despite how it feels to us. This theory, emerging from physics and philosophy, suggests that the sensation of time passing is an illusion created by consciousness, not a fundamental feature of reality itself. The universe might exist as a single, eternal block, where past, present, and future all coexist simultaneously, like pages in a book that are all equally real even though we read them one at a time. Our experience of moving through time could be similar to how we experience moving through space, except consciousness can only perceive one moment at a time, creating the feeling of flow. If this is true, then every moment that has ever existed or will exist is already laid out, permanent and unchanging. The future isn't approaching, we're simply becoming aware of it one instant at a time. This theory, called eternalism or the block universe, suggests that time is more like a dimension we inhabit than a river we're carried by, still and vast and mysterious. The arrow of time points only one direction. Time seems to move in only one direction, always forward, never back. This fundamental asymmetry, called the arrow of time, appears throughout nature. Eggs break but don't unbreak. Memories form of the past but not the future. Entropy increases but never decreases. Physicists have puzzled over why this should be, since the fundamental laws of physics work equally well running forward or backward. The answer might lie in the early universe, which began in an extraordinarily low entropy state at the Big Bang, creating a gradient down which time can flow. As the universe expands and entropy increases, this gradient gives time its direction, its arrow, its irreversible march toward disorder. We experience this as causation, as aging, as the difference between past and future. The arrow might be a consequence of cosmic history rather than a fundamental law, yet it shapes everything we know, every memory, every plan, every moment of experience flowing inevitably from order toward chaos, from structure toward dissolution. The present moment might not exist. The present moment, the now we think we inhabit, might be impossible to define. This philosophical puzzle has troubled thinkers for centuries. If time is continuous, then any moment you try to identify as now has already become the past by the time you've identified it. The present seems to have no duration, existing as an infinitesimally thin boundary between past and future, yet we undeniably experience something we call now. Some theories suggest the present is a construction of consciousness, a psychological phenomenon rather than a physical reality. Our brains might create the sensation of nowness by integrating information across a brief window of time, perhaps a few hundred milliseconds, stitching together slightly different moments into the seamless experience of the present. If true, then what we experience as now is actually a very recent past, already gone by the time we become aware of it. The present might be like the horizon, something that seems real but recedes as we approach, forever elusive, forever just beyond our grasp. Time dilation. Makes. Time. Relative to motion. Time passes at different rates depending on how fast you're moving. This consequence of Einstein's special relativity, confirmed by countless experiments, reveals that time is not absolute, but relative, stretching and compressing based on velocity. If you travelled in a spacecraft at near light speed, time would slow down for you relative to someone remaining on Earth. You might age only a few years while decades pass for them, returning to find everyone you knew grown old or gone. This isn't illusion or trickery, but fundamental reality. Time genuinely passes more slowly for objects in motion. The effect is tiny at everyday speeds, but becomes dramatic as you approach light speed. Astronauts on the International Space Station age slightly slower than people on Earth, fractions of a second over months in orbit. Time dilation shows that duration itself is not fixed but flexible, woven into the fabric of space-time, bending and stretching according to motion. What we call time is inseparable from space, both part of a unified whole that curves and flows. Gravity slows time. Near massive objects, time moves slower in stronger gravitational fields. This prediction of Einstein's general relativity means that time passes more slowly near massive objects like planets or stars than it does far away in empty space. If you stood near a black hole, time would slow dramatically for you, compared to someone watching from a distance. Hours for you might be years for them, gravity pulling on time itself, stretching moments like taffy. This effect, called gravitational time dilation, has been measured with atomic clocks at different altitudes. Clocks on mountaintops tick slightly faster than clocks at sea level, because they're farther from Earth's centre of gravity. The difference is minuscule but real, time flowing at different rates depending on where you are in a gravitational field. Near the event horizon of a black hole, time slows so much that it appears to stop completely from an outside perspective. Time and space are not separate but interwoven, both shaped by mass and energy. The universe might be cyclic and eternal time might not have a beginning or end, but instead cycle eternally through endless phases of expansion and contraction. This ancient idea, revived in modern cosmology, suggests the Big Bang wasn't the start of everything but just the beginning of this current cycle, preceded by countless others and followed by countless more. The universe expands, reaches maximum size, then contracts back into a singularity before bouncing into a new expansion, over and over forever. Each cycle might last trillions of years, with different physical laws or constants, a cosmic rhythm of birth and death and rebirth. If true, then time extends infinitely in both directions. No ultimate beginning, no final end, just endless repetition with variation. We exist in one brief moment of one cycle, among infinitely many, our entire cosmic history just one heartbeat in an eternal pulse. The theory remains speculative, difficult to test, but offers a strange comfort, that time itself might be immortal, the universe never truly dying, but always transforming, always continuing, always becoming something new from something old. Quantum mechanics suggests multiple timelines. Every quantum event might split reality into multiple timelines, each one equally real. This interpretation of quantum mechanics, called the many worlds theory, proposes that whenever a particle could take different paths, it takes all of them, but in separate branching universes. Time doesn't flow in a single line, but branches like a tree, creating new timelines with every quantum measurement, every random decay, every moment of uncertainty. This means countless versions of the past all actually happened, just in different branches, and countless futures will all actually happen, each one real, each one unfolding its own timeline. The theory solves certain quantum paradoxes but creates philosophical vertigo. If true, then time is not a single river, but an infinite delta, branching and branching forever, every possibility realized somewhere, somewhen. We experience only one branch, unaware of the others, moving through one timeline among infinitely many. The theory remains controversial, impossible to prove or disprove, but mathematically elegant, suggesting time might be far stranger than we imagine. Time might emerge from something more fundamental. Time might not be fundamental, but emergent, arising from something deeper and more basic. Some theories in quantum gravity suggest that at the smallest scales, below the Planck length, time doesn't exist at all. Instead, reality might be described by timeless quantum states, and what we experience as time emerges only at larger scales, like how temperature emerges from molecular motion, even though individual molecules don't have temperature. This would mean time is not woven into the deepest fabric of reality, but is more like a useful approximation, valid at our scale but breaking down at the most fundamental level. If true, then questions about what came before the Big Bang become meaningless because time itself didn't exist yet, emerging only as the universe expanded and cooled. The theory is highly speculative, part of ongoing attempts to unify quantum mechanics and general relativity. But it suggests that time, which feels so fundamental to existence, might be more like a shadow cast by deeper processes, real but not ultimate, present but not eternal. The speed of light might define time's pace. The speed of light might be what sets the pace of time throughout the universe. This fundamental constant, approximately 300,000 kilometers per second, appears in the equations linking space and time, suggesting it's not just the speed of light but the speed of causality itself, the maximum rate at which cause can lead to effect. If light travelled faster or slower, time would flow differently, moments stretching or compressing to accommodate the change. Some theories propose that the speed of light might have varied in the early universe, which would mean time itself flowed at different rates then, the universe aging faster or slower depending on this cosmic speed limit. The connection between light speed and time flow reveals something profound, that time is not independent of the physical universe, but deeply entangled with it, shaped by the same forces that govern light and matter and energy. The speed of light might be the heartbeat of space-time, setting the rhythm by which all events unfold, all changes occur, all moments succeed one another in the endless dance of causation. Entropy might be why we remember the past. We remember the past but not the future because of entropy, the tendency of systems to become more disordered over time. This thermodynamic arrow of time explains not just why eggs break, but why memory works the way it does. Memories are physical traces, ordered structures in our brains that can only form because entropy is increasing. Recording information requires creating order, which produces waste heat, increasing entropy overall. In a universe running backward, where entropy decreased, we would remember the future and be ignorant of the past, causation reversed. The fact that we remember yesterday but not tomorrow is not a fundamental feature of consciousness but a consequence of thermodynamics, of the universe's journey from low entropy at the Big Bang toward maximum entropy in the far future. Memory itself is an arrow, pointing the same direction as time toward increasing disorder. This theory connects the subjective experience of time with the objective physics of the universe, suggesting that consciousness is not separate from physical law, but shaped by it, our minds flowing with time's current. The past exists as surely as the present, just elsewhere in space-time. This view, part of the block universe theory, suggests that moments don't cease to exist when they become past, any more than places cease to exist when you leave them. Yesterday is still there, back along the time dimension, as real as it ever was, simply not accessible to your current position in space-time. If you could travel backward through time, you would find the past exactly as it was, not as a memory or reconstruction, but as actual reality, still happening, still present to itself. This means that every moment of history continues to exist eternally, frozen in the four-dimensional structure of space-time. Your birth is still happening, your childhood still unfolding, every joy and sorrow still present somewhere in the block. The feeling that the past is gone is an illusion of consciousness, which can only experience one moment at a time. If this theory is correct, then nothing is ever truly lost, all moments preserved forever in the eternal structure of the universe. Time not destroying, but merely organizing, arranging all events into a vast, unchanging tapestry. The future might already exist, laid out and determined, waiting for us to arrive. This deterministic view of time suggests that everything that will happen has already happened, in a sense, existing in the future regions of the block universe just as surely as the past exists in the past regions. If true, then free will becomes puzzling. How can we choose our actions if the future is already real and fixed? Some philosophers argue that even in a determined universe, choice remains meaningful because we don't know the future, and our decisions are still ours, even if they were always going to happen. Others suggest that the future might exist in multiple versions, all equally real, with our choices determining which branch we experience. The question remains open, troubling, beautiful in its way. The theory that the future exists challenges our deepest intuitions about time, about possibility, about what it means to live in the present moment when past and future might be equally real, equally eternal, equally beyond our power to change. Time might be quantized, made of discrete moments rather than flowing continuously. Some theories in quantum gravity suggest that time, like energy and space, comes in smallest possible units, indivisible instants called chronons. If true, then time doesn't flow smoothly but ticks forward in tiny jumps, too small to detect but fundamentally granular, like frames in a film creating the illusion of continuous motion. Each chronon might last around 10⁻43 seconds, the Planck time, the smallest duration that has physical meaning. Below this scale, the concepts of before and after might break down entirely, time itself dissolving into quantum foam. This quantization would mean the universe doesn't evolve smoothly, but updates in discrete steps, reality refreshing like a cosmic computer screen, each moment separate from the next. The theory remains speculative, untestable with current technology, but suggests that time's apparent smoothness might be an illusion of scale. The way a beach seems smooth until you notice the individual grains of sand, each moment distinct, each instant separate, time built from pieces too small to see. Our perception of time might be constructed by consciousness rather than directly experienced. The brain receives information about events, but these signals arrive at different speeds and are processed at different rates, creating a puzzle. How do we experience a unified present moment when the brain's information about that moment is scattered across time? Some neuroscientists suggest that consciousness constructs the experience of now by integrating information across a brief window, perhaps 200–300 milliseconds, stitching together slightly different moments into the seamless sensation of the present. This means what we experience as now is actually a very recent past, already gone by the time we become aware of it. The brain is constantly editing reality, creating the illusion of a present moment from fragments of past information. If true, then our experience of time is not a direct perception of reality, but a useful fiction, a story the brain tells itself to make sense of the constant stream of delayed and scattered signals. Time as we know it might be more like a dream than a direct experience, consciousness painting over the gaps. If your mind is starting to wander, that's perfectly fine. These theories aren't meant to be memorized, only experienced, like watching clouds drift across the sky. Time might be an illusion created by change and memory. Some philosophers argue that time doesn't exist independently, but is simply our way of organizing the experience of change, of events following one another in causal sequences. Without change, without events succeeding one another, would time have any meaning? If the universe were completely static, nothing moving or transforming, would time still pass? This theory suggests that time is not a container in which events happen, but a relationship between events, a way of describing how things change. Memory reinforces this illusion, creating the sense of a past that no longer exists. But perhaps all that really exists is the present configuration of the universe, which includes records of different configurations, and we call these records memories. The past might not be real, the future not yet exist, leaving only the eternal now, constantly changing, constantly new. This view dissolves time into process, into becoming, into the endless transformation of reality, suggesting that duration itself might be a mental construct rather than a physical reality, a useful way to think but not a fundamental truth. Time travel to the past might be possible through closed time-like curves. General relativity allows for solutions where space-time curves back on itself, creating loops in time where you could return to your own past. These closed time-like curves emerge naturally from certain configurations of mass and energy, though whether they exist in our universe remains unknown. If you followed such a curve, you would move forward through time from your own perspective, but eventually arrive back at a moment you'd already experienced, time forming a circle rather than a line. This creates paradoxes. What if you prevented your own birth, or changed the past in ways that would make your time travel impossible? Some physicists suggest that consistency might be enforced by quantum mechanics, ensuring that only self-consistent histories can occur. Others propose that changing the past creates a new timeline, leaving the original unchanged. The mathematics allows time travel, but nature might forbid it through mechanisms we don't yet understand. The possibility remains open, tantalizing, suggesting that time might be more flexible than we imagine, capable of loops and tangles and strange topologies. The universe might exist in a state where all times are equally present, with no objective past or future. This view, called the eternal present or the timeless universe, suggests that what we experience as time passing is actually just our consciousness moving through a static four-dimensional structure. All moments exist simultaneously, like frames of a film all present on the reel, even though we watch them one at a time. The universe doesn't evolve or change, it simply is, complete and eternal, containing all of history and all of future in a single timeless reality. Our sensation of time passing is a feature of consciousness, not of the universe itself, which remains forever still, forever complete. If true, then the Big Bang and the heat death of the universe are both eternally present, not past and future, but simply different regions of space-time, all existing together in a vast, unchanging whole. This theory offers a strange peace. Nothing is ever truly lost because everything always exists, somewhere in the eternal structure, time not destroying, but merely organizing, all moments preserved forever in the timeless now. Time might be cyclic on cosmic scales, with the universe repeating itself endlessly. This idea, found in ancient philosophies and modern physics, suggests that after an unimaginably long time, perhaps Tessus 10 or 56 years, the universe will return to exactly the same state it started in, and everything will happen again, identically, forever. This eternal recurrence emerges from the mathematics of probability. In an infinite universe or infinite time, every possible configuration must eventually repeat. If true, then you have lived this exact life infinitely many times before, and will live it infinitely many times again, every moment recurring eternally. Some find this thought comforting, others horrifying, but it suggests that time might be circular rather than linear, the end curving back to the beginning. Each cycle would be indistinguishable from the last, no memory carrying over, just endless repetition. The theory is impossible to prove or disprove, but it offers a vision of time as eternal return, the universe a cosmic loop, everything that has happened destined to happen again and again forever, time itself a circle with no beginning and no end. The subjective experience of time speeds up as we age because we process fewer novel experiences. When we're young, everything is new, and the brain encodes rich, detailed memories, making time seem to pass slowly. As we age, life becomes more routine, and the brain encodes less detail, making time seem to accelerate. A year to a 5-year-old represents 20% of their entire life and is filled with countless new experiences, while a year to a 50-year-old represents only 2% of their life and may contain far fewer memorable moments. This theory suggests that time's pace is not objective but depends on memory formation and novelty. The more new experiences we have, the slower time seems to pass in retrospect. This is why childhood summers seemed endless while adult years fly by, why vacation weeks feel long while working weeks feel short. Time's subjective pace might be under our control to some extent. By seeking new experiences and staying present, we might slow the feeling of time's passage, making our lives feel longer, richer, more full of moments worth remembering. The universe might exist in superposition, experiencing all possible timelines simultaneously until observed. This quantum view of cosmic time suggests that reality doesn't follow a single timeline, but exists in a superposition of all possible histories at once. Like Schrödinger's cat being both alive and dead until someone looks. Only when a measurement occurs does the universe collapse into a single, definite history, choosing one timeline from the infinite possibilities. If true, then the past might not be fixed but fluid, changing depending on what we observe in the present. Quantum experiments hint at this strange possibility, suggesting that the past is not definitively real until it's measured, and measurement in the present can affect which past actually occurred. This would mean time is not a simple progression from past to future, but a complex web of possibilities, with the present moment constantly reaching back to solidify history, choosing which past becomes real. The theory challenges everything we think we know about causation and time, suggesting that the universe's history might be less like a recording and more like a story being written as we observe it. Black holes might destroy time at their centers, creating singularities where time ceases to exist. At the event horizon, time slows dramatically, and at the singularity, according to general relativity, space-time curvature becomes infinite, and the equations break down. Some physicists interpret this as meaning that time itself ends at the singularity, that there is no future beyond that point, no moments following, just a boundary where time stops. If you fell into a black hole, from your perspective you would reach the singularity in finite time, but what happens there remains one of physics' deepest mysteries. Perhaps time transforms into something else. Or perhaps the singularity represents a genuine end of time, a place where the concept of before and after loses meaning. The mathematics suggests that singularities are real, but many physicists hope that a theory of quantum gravity will reveal that singularities don't actually form, that something prevents time from truly ending. Until then, black holes remain cosmic mysteries, where time itself might die, swallowed by gravity, erased from existence, leaving only darkness and silence. Time might be emergent from quantum entanglement, the strange connection between particles. Some theoretical physicists propose that space-time itself, including time, emerges from the entanglement structure of quantum systems. In this view, time is not fundamental, but arises from the pattern of correlations between quantum states, like how temperature emerges from molecular motion. If true, then at the deepest level, there is no time, only timeless quantum information, and what we experience as time passing is the evolution of entanglement patterns. This would mean that time is a large-scale phenomenon, valid at our scale but breaking down at the quantum level, where reality is timeless and purely quantum. The theory is highly speculative, part of cutting-edge research in quantum gravity, but it suggests a radical reimagining of time's nature. If time emerges from entanglement, then understanding time requires understanding quantum correlations, and the flow of time might be fundamentally connected to the flow of quantum information through entangled systems. Time would be woven from quantum threads, a tapestry of correlations that creates the experience of duration, of succession, of moments following one another in the dance of causation. The psychological present might last about 3 seconds, the duration over which we perceive events as simultaneous. Studies of consciousness suggest that the brain integrates information over a window of roughly 3 seconds, creating what psychologists call the specious present, the span of time that feels like now. Events within this window seem to happen at the same time, while events outside it feel separated in time. This is why we can perceive a melody as a unified whole rather than as individual notes, or understand a sentence as a complete thought rather than as separate words. The 3-second window might represent a fundamental limit of consciousness, the maximum span over which the brain can maintain a unified sense of nowness. If true, then what we experience as the present moment is actually a brief film clip, 3 seconds long, constantly updating as time passes. The past is everything before this window, the future everything after, and the present is this moving 3-second span in which we live. Time's subjective texture might be determined by this cognitive architecture, consciousness, painting the present moment from fragments of the very recent past. Cosmic inflation might have created time by expanding space exponentially in the first fraction of a second after the Big Bang. Before inflation, the universe might have been in a timeless quantum state, with no clear distinction between past and future. Inflation created time by breaking the symmetry of this timeless state, giving the universe a direction, an arrow, a flow from past to future. The rapid expansion stretched quantum fluctuations into the seeds of galaxies, creating the structure we see today. But it also created the time in which this structure could evolve. If true, then time is not eternal but had a beginning, emerging from a timeless quantum state through the process of cosmic inflation. This would mean that asking what came before the Big Bang is meaningless because time itself didn't exist yet, only coming into being as the universe expanded. Time might be a feature of our particular universe, not a universal necessity, something that could have been different or absent entirely. The theory remains speculative but offers a possible answer to one of cosmology's deepest questions. Where did time come from? Time dilation near black holes creates a strange effect where someone falling in would see the entire future history of the universe flash by. From the perspective of someone watching from far away, an object falling toward a black hole appears to slow down as it approaches the event horizon, taking infinite time to actually cross it, frozen forever at the boundary. But from the perspective of the falling object, time passes normally, and they cross the horizon in finite time, experiencing nothing special at that moment. This creates a paradox. The falling object crosses the horizon from their perspective, but never crosses it from the outside perspective. Both views are equally valid, showing that time is not absolute but depends on your position and motion. Near the event horizon, time becomes so warped that past, present, and future blur together, causation becomes unclear, and the normal flow of time breaks down. Black holes are not just objects in space, but distortions in space-time itself, places where time behaves so strangely that our intuitions fail completely. The universe might have no beginning in time if time itself is emergent from quantum gravity. Some theories propose that the Big Bang was not the start of time, but a transition from a timeless quantum state to a classical universe where time exists. In this view, asking what came before the Big Bang is like asking what's north of the North Pole, a question that assumes time exists when it might not have. The universe might be eternal in a timeless sense, with no first moment, no beginning, because time itself only emerged later. This would resolve the puzzle of how something could come from nothing. Because in the timeless quantum state, there is no nothing, no something, just pure quantum possibility. Time would be a feature of our universe, not a fundamental aspect of reality, something that could vary or be absent in other contexts. The theory remains highly speculative, requiring a complete theory of quantum gravity to fully develop. But it suggests that time might be less fundamental than we imagine, a useful concept at our scale, but not an ultimate feature of existence. If your eyes are growing heavy, don't fight it. Sleep is welcome here. The theories will continue whether you hear them or not, a quiet voice in the darkness. Time might flow at different rates in the different regions of the universe, creating a cosmic patchwork of varying time speeds. This consequence of general relativity means that there is no universal now, no single present moment that extends across the entire cosmos. Instead, simultaneity is relative, depending on motion and gravity, with different observers disagreeing about which events are happening at the same time. If an alien civilization exists on a distant planet, what they consider now might be our past or our future, depending on their motion relative to us. This relativity of simultaneity shows that the present moment is not an objective feature of the universe, but depends on perspective. Time is woven into the fabric of space-time, and that fabric is curved and stretched differently in different places, creating a universe where time itself is not uniform but varies from place to place. The theory is well established, confirmed by countless experiments, but its implications remain strange. That there is no universal present, no cosmic now, just countless different presents, each one equally valid, each one defining its own flow of time through the universe. The arrow of time might reverse in contracting universes, with entropy decreasing and effects preceding causes. If the universe eventually stops expanding and begins contracting, some theories suggest that time's arrow would reverse, with the future becoming the past and the past becoming the future. Entropy would decrease as the universe contracted, broken eggs would reassemble, and memories would form of the future rather than the past. Consciousness in such a universe would experience time flowing in the opposite direction, but from their perspective, everything would seem normal, with causes preceding effects and entropy increasing, because their psychological arrow of time would also reverse. This theory suggests that time's direction is not fundamental, but depends on the universe's expansion or contraction, with the arrow of time always pointing toward increasing entropy, whether that means toward the Big Bang or toward the Big Crunch. The theory remains speculative, depending on whether the universe will eventually contract, but it offers a vision of time as flexible, capable of flowing in either direction depending on cosmic conditions, not fixed, but adaptable, not absolute but contingent on the universe's evolution. Time might be a dimension similar to space, with the future and past existing as surely as distant places. This view, central to relativity, treats time as a fourth dimension, perpendicular to the three dimensions of space, creating a four-dimensional space-time continuum. Just as places don't cease to exist when you're not there, times don't cease to exist when they're not now. The past is back there in the time dimension, the future up ahead, both as real as distant cities or far galaxies. We can't travel freely through time the way we travel through space, but that's a limitation of our biology and technology, not a fundamental feature of time itself. The dimension is there, extending in both directions, and we move through it at a rate of 1 second per second, unable to stop or turn around. This four-dimensional view of reality dissolves the distinction between space and time, showing them to be aspects of a unified whole, space-time curved by mass and energy, flexible and dynamic, the stage on which all events unfold. Quantum mechanics might allow particles to move backward in time, appearing to us as antimatter moving forward. This interpretation, proposed by physicist Richard Feynman, suggests that an antiparticle is simply a particle moving backward through time. When matter and antimatter annihilate, it might be a single particle moving forward and then backward in time, creating a loop. This would mean that the distinction between past and future is not absolute even at the quantum level, with particles able to violate our intuitive sense of time's direction. The mathematics of quantum field theory treats particles and antiparticles symmetrically, suggesting that time symmetry might be more fundamental than we realize. If true, then the quantum world is even stranger than we thought, with particles weaving through time in both directions, creating the appearance of matter and antimatter when viewed from our time-forward perspective. The theory remains controversial, but it offers a vision of time as more flexible at the quantum level, where causation becomes fuzzy, and the distinction between past and future blurs into quantum uncertainty, time itself becoming probabilistic and strange. The universe's age might be infinite if time is cyclic and eternal, with no beginning or end. This ancient idea, revived in modern cosmology, suggests that the Big Bang was not the start of time, but just one event in an endless series of expansions and contractions. If true, then time extends infinitely into the past and infinitely into the future, with no first moment and no last moment, just endless cycles of cosmic birth and death. Each cycle might last trillions of years, with the universe expanding, reaching maximum size, contracting back to a singularity, and then bouncing into a new expansion. The cycles might be identical or might vary, with different physical laws or constants in each iteration. This eternal universe would mean that time has no beginning to explain, no ultimate origin, because it has always existed and always will exist. The theory remains speculative, difficult to test, but offers a vision of time as truly infinite, not just lasting a long time, but having no start or end, stretching eternally in both directions, the universe never created and never destroyed, just endlessly transforming through cycles we can barely imagine. Time might be holographic, with all information about the universe's history encoded on its boundary. This idea, related to the holographic principle, suggests that the four-dimensional space-time we experience might be a projection from a three-dimensional boundary, like a hologram emerging from a flat surface. If true, then time itself might be holographic, with the entire history of the universe encoded in timeless information on a distant boundary. The flow of time we experience would be an illusion created by this holographic projection, not fundamental but emergent from deeper timeless structures. This theory attempts to reconcile quantum mechanics with gravity, suggesting that space-time itself, including time, is not fundamental, but arises from quantum information encoded on boundaries. The mathematics is complex and the theory highly speculative, but it offers a radical reimagining of time's nature, that duration, succession, and flow might all be projections from a timeless reality, shadows cast by deeper structures we cannot directly perceive, time itself a kind of cosmic hologram, real but not ultimate, present but not fundamental. Consciousness might create time by collapsing quantum superpositions into definite states. Some interpretations of quantum mechanics suggest that consciousness plays a role in determining reality, with observation causing quantum possibilities to collapse into actualities. If true, then consciousness might also create time, with the flow of time emerging from the process of observation and measurement. In this view, time would not exist independently of conscious observers, but would be generated by the act of observation, with each measurement creating a new moment, a new now, advancing time forward. Without consciousness, the universe might exist in a timeless superposition of all possible states, with no definite past or future. Consciousness would break this symmetry, choosing one possibility from the infinite superposition, creating a timeline, a history, a definite sequence of events. The theory is controversial and difficult to test, but it suggests that time and consciousness might be deeply connected, with the subjective flow of time emerging from the objective process of quantum measurement, mind and time woven together in ways we're only beginning to understand. The far future of the universe might be timeless, with no events occurring and no changes happening. As the universe expands and cools, stars will eventually burn out, black holes will evaporate, and all matter will decay into radiation. In this heat-death scenario, the universe will reach maximum entropy, a state of perfect equilibrium where no energy flows, no work can be done, and nothing changes. In such a universe, would time still exist? If time is defined by change, by events succeeding one another, then a perfectly static universe might be timeless, with no distinction between past and future, no flow, no duration. The universe would exist in an eternal, unchanging state, not frozen in time but beyond time, in a condition where the concept of time has no meaning. This far future might be as timeless as the universe's beginning, with time existing only in the middle, during the brief cosmic era when change is possible. The theory suggests that time itself might be temporary, a feature of our particular epoch, destined to end when the universe reaches equilibrium, leaving only eternal, timeless stillness. Time might be discrete at the smallest scales, with a minimum possible duration called the Planck time. This quantum of time, approximately 5.4 skiast, 10^, 44 seconds, represents the smallest meaningful interval, below which the concepts of before and after might lose meaning. If time is truly quantized, then it doesn't flow smoothly, but advances in tiny, indivisible jumps, like frames in a film, creating the illusion of continuous motion. Each Planck time would be a separate moment, disconnected from the next, with the universe updating in discrete steps rather than evolving continuously. This quantization would mean that time's apparent smoothness is an illusion of scale, visible only because we experience durations vastly longer than the Planck time. At the fundamental level, time might be granular, made of pieces, each piece the smallest possible moment. The theory remains speculative, part of attempts to unify quantum mechanics with general relativity, but it suggests that time, like space and energy, might come in smallest possible units, reality itself pixelated at scales far too small to detect, time built from atoms of duration too brief to measure. The universe might branch at every quantum event, creating a tree of timelines that never merge. This many worlds interpretation suggests that reality doesn't choose between quantum possibilities, but realizes all of them in separate parallel timelines. Every time a particle could go left or right, both happen, but in different branches of the universal wave function. This means the past is not a single line, but a vast tree, with countless branches representing different possible histories. And the future is not one timeline, but infinitely many, all equally real, all unfolding simultaneously. We experience only one branch, our timeline, unaware of the countless others where different versions of us made different choices or where random quantum events went differently. If true, then time is not a river but a delta, branching endlessly, every possibility realized somewhere in the vast tree of timelines. The theory is mathematically elegant but philosophically troubling, suggesting that every moment splits reality into countless copies, each one real, each one experiencing its own flow of time through an infinite multiverse of possibilities. Time perception might be altered by temperature, with warmer environments making time seem to pass faster. Studies suggest that body temperature affects the brain's internal clock, with higher temperatures speeding up neural processes and making time seem to pass more quickly. This might explain why time seems to fly in summer and drag in winter, why fever makes hours blur together, why cooling the brain can slow subjective time. The effect is subtle but measurable, suggesting that time perception is not fixed, but depends on physical conditions, including temperature. If true, then our experience of time's pace is partly determined by thermodynamics, by the speed of chemical reactions in our brains, which vary with temperature. This would mean that time's subjective flow is not purely psychological, but has a physical basis, rooted in the temperature-dependent kinetics of neural processes. Time would feel different to creatures with different body temperatures, with cold-blooded animals potentially experiencing time at different rates than warm-blooded ones, each species living in its own temporal world, time's pace set by biology and physics, not by some universal clock, but by the particular rhythms of each organism's metabolism. The Big Bang might not have been the beginning of time, but a transition from one state to another. Some theories propose that before the Big Bang, the universe existed in a different form, perhaps contracting from a previous expansion, perhaps in a quantum state with different properties. The Big Bang would then be a boundary between two eras, not an absolute beginning, with time extending backward beyond it into a previous epoch. This would mean that time is older than our universe, that the Big Bang created not time itself, but only our particular cosmic era. With time continuing from whatever came before, the theory is difficult to test because the Big Bang appears to erase all information about any previous state, like a cosmic reset button. But if time existed before the Big Bang, then questions about ultimate origins remain unanswered, pushed back to an earlier beginning or perhaps to no beginning at all, with time extending infinitely into the past. The theory suggests that the Big Bang, rather than being the start of everything, might be just one event in a much longer, perhaps eternal cosmic history, time flowing through the Big Bang like a river flowing through a waterfall, continuous despite the dramatic transition. Gravity might be the force that creates time, with time emerging from gravitational interactions. Some theories in quantum gravity propose that time is not fundamental, but arises from the way gravity connects different parts of the universe. In this view, time would be a relational concept, defined by how gravitational interactions create correlations between events. Without gravity, without mass and energy curving space-time, time might not exist at all, leaving only a timeless quantum state. This would mean that time is a consequence of matter and energy, not a container in which they exist, with the flow of time emerging from the dynamic evolution of gravitational fields. If true, then understanding time requires understanding gravity at the quantum level, and the nature of time might be revealed by a complete theory of quantum gravity. Time would be woven from gravitational threads, a tapestry of interactions that creates the experience of duration, of succession, of moments following one another. The theory remains highly speculative, but it suggests that time and gravity might be more deeply connected than we realize, with time itself a gravitational phenomenon emerging from the curvature of space-time, inseparable from the mass and energy that shape the universe. If some theories feel confusing, that's okay. They're meant to be felt more than understood, like music you don't need to analyze to enjoy. The concept of simultaneity might be meaningless across cosmic distances, with no objective way to define which events happen at the same time. This consequence of relativity shows that two observers moving relative to each other will disagree about whether distant events are simultaneous, with no way to determine who is right because both perspectives are equally valid. This means that there is no cosmic now, no universal present moment extending across the universe, just countless different presents depending on motion and perspective. If an event happens in a distant galaxy, we cannot say whether it's happening now, in our past or in our future, without specifying a reference frame. The question has no objective answer, only relative answers depending on the observer. This relativity of simultaneity shows that time is not a universal framework but a local phenomenon, with each observer experiencing their own time, their own present, their own flow from past to future. The universe has no single timeline but countless timelines, all equally valid, all woven together into the complex structure of space-time. Time itself becoming relative, flexible, dependent on motion and gravity, not absolute but contingent. Time might stop at absolute zero, where all motion ceases and entropy reaches its minimum. At this coldest possible temperature, particles would have minimal energy, quantum fluctuations would be at their lowest, and change would slow to nearly nothing. Some theories suggest that at absolute zero, time itself might stop. With no events occurring, no processes unfolding, reality frozen in a timeless state. If time is defined by change, and change requires energy, then at absolute zero, time might lose its meaning. The universe would exist in a static configuration, neither past nor future, just an eternal present with no flow, no duration, no succession of moments. This state is impossible to reach in practice, as quantum mechanics prevents perfect stillness, but it represents a theoretical limit where time approaches zero pace. The theory suggests that time and energy are connected, with time's flow depending on the availability of energy to drive change. In a universe that has reached heat death, with all energy evenly distributed and no gradients to drive processes, time might effectively stop, not because it's frozen, but because nothing changes, leaving only timeless equilibrium. The psychological sense of time passing might be an illusion created by memory and anticipation. Without memory of the past or anticipation of the future, would we experience time as flowing? Some philosophers argue that the sensation of time passing requires comparing the present to remembered pasts and anticipated futures, creating the feeling of movement through time. An organism without memory might experience only an eternal present, each moment completely new, with no sense of duration or flow. This suggests that time's passage is not directly perceived but constructed by consciousness from memory and expectation. We don't feel time passing. We infer it from the fact that the present differs from what we remember and from what we expect. The flow of time might be a cognitive illusion, useful for navigating reality but not corresponding to anything in the external world. If true, then time as we experience it is a creation of mind, not a feature of the universe, with the objective world being timeless, and only consciousness creating the sensation of temporal flow, painting time onto a timeless reality, adding duration to an eternal present. Cosmic strings, if they exist, might create closed time-like curves that allow time travel. These hypothetical defects in space-time, left over from the early universe, would be incredibly dense and long, stretching across cosmic distances. Their extreme gravity would warp space-time so severely that loops in time might form around them, allowing objects to travel backward in time by following certain paths. If you moved around a cosmic string in the right way, you could return to your own past, creating all the paradoxes associated with time travel. The theory is speculative, as cosmic strings have never been observed, but general relativity allows for their existence and predicts their time-bending properties. If they exist, they would be among the strangest objects in the universe, places where time itself becomes tangled, where past and future loop back on themselves, where causation breaks down. The possibility of cosmic strings suggests that time travel might not be forbidden by the laws of physics, only by the absence of the right conditions, with time remaining flexible enough to allow journeys backward if the universe contains the right structures. Time might be fundamentally asymmetric, with the future different from the past in ways we don't fully understand. While the laws of physics are mostly time-symmetric, the universe itself is not, with entropy increasing, causation flowing forward, and memory recording the past but not the future. This asymmetry might be fundamental, built into the structure of reality at a deep level, or it might be a consequence of initial conditions, with the universe starting in a low-entropy state that creates the arrow of time. Some theories suggest that time asymmetry is connected to the expansion of the universe, with the direction of time linked to the direction of cosmic growth. If the universe were contracting, time might flow backward, with the arrow of time always pointing toward increasing entropy, whether that means toward the Big Bang or toward the Big Crunch. The asymmetry of time remains one of physics' great mysteries, a feature of reality that seems fundamental but might emerge from deeper principles we haven't yet discovered. Time flows in one direction, irreversibly, inexorably, carrying everything from past to future, from order to disorder, from birth to death. A cosmic river that never reverses, never stops, never allows us to return to moments that have passed. The multiverse might contain regions with different time dimensions, some with multiple times or no time at all. If the multiverse is real, with countless universes having different physical laws, then time itself might vary from universe to universe. Some might have 2 or 3 time dimensions, creating strange causality where events can be connected in multiple temporal directions. Others might have no time dimension at all, existing in a timeless state where nothing changes or evolves. Our universe, with its single time dimension flowing from past to future, might be just one possibility among many. In universes with multiple time dimensions, the concept of causation would be radically different, with events potentially causing themselves or with causal loops being common. In timeless universes, nothing would happen. No events would succeed one another. Reality would simply be static and eternal. This multiverse view suggests that time is not a universal necessity, but a contingent feature, something that could be different or absent, with our experience of time being specific to our particular universe, not representative of reality as a whole. Time might dilate not just from motion and gravity, but from acceleration itself. Einstein's equivalence principle shows that acceleration is indistinguishable from gravity, which means accelerating observers should experience time dilation, similar to gravitational time dilation. This has been confirmed experimentally. Accelerating clocks run slower than stationary ones, with the effect proportional to the acceleration. This means that any change in velocity affects time's flow, with time slowing during acceleration and speeding during deceleration. The effect is tiny at everyday accelerations, but becomes significant at extreme values. If you could accelerate to near light speed and then decelerate back to rest, you would experience less time than someone who remained at constant velocity, aging slower, experiencing fewer moments. This shows that time is not just affected by where you are in space-time, but by how you move through it, with acceleration creating time dilation independent of gravity. Time becomes more flexible the more we study it, bending and stretching in response to motion, gravity, and acceleration, revealing itself as deeply woven into the fabric of space-time, inseparable from the geometry of the universe. The experience of déjà vu might be a glitch in time perception, where the brain incorrectly timestamps a present experience as a memory. This neurological explanation suggests that déjà vu occurs when the brain's memory system misfires, creating the feeling that you've experienced the current moment before. The present is accidentally stored as a memory before you consciously experience it, creating the uncanny sensation of remembering something that's happening now. This would mean that déjà vu is not a glimpse of a parallel timeline or a memory from a past life, but simply a timing error in the brain's processing of experience. The theory is supported by the fact that déjà vu is more common in people with temporal lobe epilepsy, suggesting it's related to how the brain handles temporal information. If true, then déjà vu reveals something about how consciousness constructs time, showing that the feeling of pastness is not inherent in experiences, but added by the brain's memory systems. Time perception is not passive, but active, with the brain constantly labeling experiences as past, present, or future, and sometimes making mistakes, creating strange temporal illusions that feel like glitches in time itself. The arrow of time might be local rather than universal, with different regions of the universe experiencing time in different directions. Some theories suggest that in a sufficiently large or infinite universe, there might be regions where entropy decreases rather than increases, creating local reversals of time's arrow. In these regions, which would be incredibly rare and far apart, time would flow backward from our perspective, with effects preceding causes and the future becoming the past. Consciousness in such regions would experience time flowing normally from their perspective, with their psychological arrow aligned with their local thermodynamic arrow, but they would be moving backward through time relative to us. This would create a universe where time has no single direction, but flows differently in different places, with some regions moving forward and others backward. The theory is highly speculative, but it suggests that time's arrow might not be a universal feature, but a local accident, with our region of the universe happening to have increasing entropy, while other regions might have different temporal directions, creating a cosmos where time itself varies from place to place. Time might be the dimension along which entropy increases, defining time's direction by the second law of thermodynamics. This view suggests that time is not independent of entropy, but defined by it, with the past being the direction of lower entropy, and the future the direction of higher entropy. If entropy didn't increase, if the universe were in perfect equilibrium, time might have no direction, no arrow, no distinction between past and future. The flow of time would be an illusion. With all moments equally present, no preferred direction of causation. This theory connects time deeply with thermodynamics, suggesting that understanding time requires understanding entropy, and that time's arrow is not a separate mystery but a consequence of the second law. If true, then time is emergent from thermodynamics, not fundamental, but arising from the statistical behavior of large numbers of particles. The past is different from the future because the past had lower entropy, and the future will have higher entropy, creating an asymmetry that we experience as time's flow. Time becomes a thermodynamic phenomenon, inseparable from entropy, defined by the universe's journey from order to disorder, from structure to chaos, from the Big Bang's low entropy toward the heat death's maximum entropy. Quantum entanglement might allow instantaneous correlations across space but not through time. When two particles are entangled, measuring one instantly affects the other, regardless of distance. But this doesn't allow faster-than-light communication or violation of causality. The correlations are instantaneous across space but don't propagate backward through time, preserving causality even while seeming to violate locality. This suggests that space and time are fundamentally different, with time having special properties that prevent causal paradoxes. Entanglement shows that the universe is deeply connected in ways that transcend space, with particles maintaining correlations across cosmic distances. But these connections respect time's arrow, never allowing effects to precede causes. The theory reveals something profound about time's nature, that it has a direction that cannot be violated, even by quantum mechanics' strangest phenomena. Time remains one-directional, flowing from past to future, even when space becomes almost irrelevant, suggesting that time's arrow is more fundamental than space's structure, more deeply woven into reality's fabric, more essential to the universe's basic nature. The concept of eternity might be different from infinite time, representing a state outside of time altogether. Philosophers distinguish between sempiternity, which is infinite duration, and eternity, which is timelessness. Something sempiternal exists at all times, past, present, and future, never beginning and never ending, but still within time. Something eternal exists outside of time, not lasting forever but transcending duration entirely, experiencing no succession of moments, no flow from past to future. If God or abstract objects like numbers exist eternally in this sense, they don't endure through time but exist timelessly, all at once, without before or after. This distinction suggests that time might not be all-encompassing, that there might be modes of existence not subject to temporal flow. Eternity would be a different kind of being, not temporal, but atemporal, not changing, but changeless, not moving through time, but simply being, timelessly, eternally, in a way that consciousness bound to time cannot fully comprehend. The concept stretches our understanding, suggesting that time might be a local feature of our universe, not a universal necessity, with other forms of existence possible beyond time's reach. There's no test at the end. No need to prove you were listening. Your mind can wander where it wants, to memories, to dreams, to nothing at all. The Planck epoch, the first 10 or 43 seconds after the Big Bang, might have been timeless in a quantum sense. At such extreme energies and densities, quantum effects would dominate gravity, and space-time itself would break down into quantum foam, a seething mass of virtual particles and fluctuating geometry. In this regime, the concepts of before and after might lose meaning, with time itself becoming uncertain, probabilistic, not yet crystallized into the classical dimension we experience. This would mean that the very first moment of the universe was not really a moment at all, but a quantum superposition of all possible times, with time emerging only as the universe expanded and cooled. The Planck epoch represents a boundary of knowledge, a limit beyond which our current theories cannot see, where quantum mechanics and general relativity both fail. Understanding what happened then might require a complete theory of quantum gravity, which would reveal whether time truly had a beginning or whether it emerged from something more fundamental, something timeless and strange. A quantum state from which time itself was born. The subjective experience of time might be infinitely divisible, with consciousness capable of experiencing arbitrarily small durations. While physics suggests that time might be quantized at the Planck scale, consciousness might be able to divide time infinitely, experiencing smaller and smaller durations without limit. This would create a strange situation where physical time has a minimum unit, but psychological time does not, with consciousness capable of finer temporal resolution than reality itself. The theory is speculative, but it suggests that the relationship between physical time and experienced time might be more complex than we assume. Perhaps consciousness doesn't directly perceive physical time, but constructs its own temporal experience, which could have different properties, different granularity, different structure. If true, then the time we experience might be a mental construct only loosely related to physical time, with consciousness creating its own temporal dimension, its own flow, its own succession of moments, independent of the physical universe's temporal structure. Time would be both physical and psychological, both objective and subjective, both real and constructed, a strange hybrid of external reality and internal experience. Time might be the dimension that consciousness moves through, while space is the dimension consciousness occupies. This philosophical view suggests that our experience of time passing is actually consciousness moving along the time dimension, like a spotlight moving along a film strip, illuminating one frame at a time. We experience the present because that's where consciousness currently is, and we remember the past because consciousness has already passed through those moments, leaving traces. The future is ahead, not yet experienced, waiting for consciousness to reach it. This would mean that time's flow is not a property of the universe but of consciousness, with the universe itself being timeless, a four-dimensional block containing all moments, and consciousness creating the experience of flow by moving through it. The theory is difficult to test but offers an explanation for why time feels so different from space. We can move freely through space, but only forward through time because consciousness is constrained to move in one direction, through the time dimension, creating the arrow of time, the flow from past to future, the irreversible march of moments that defines our experience of existence. The heat death of the universe might not be the end of time, but a transition to a new kind of time. After all stars have burned out and all black holes have evaporated, the universe will exist in a state of maximum entropy, with no energy gradients to drive processes. But some theories suggest that even in this state, quantum fluctuations might occasionally create small regions of lower entropy, like Boltzmann brains or even new universes. These fluctuations would be incredibly rare, separated by unimaginable spans of time, but they would mean that time continues even in the heat death, just at an almost imperceptibly slow pace. The universe would exist in a kind of eternal twilight, mostly unchanging but occasionally sparking with brief moments of activity. Time would still flow, but so slowly that nothing meaningful would happen for eons, with rare fluctuations breaking the monotony. This vision of the far future suggests that time might be eternal, continuing even when the universe has reached equilibrium, stretching infinitely into a future where change is rare but not impossible, where time persists even when almost nothing happens, a cosmic patience beyond imagining. The twin paradox shows that time is not absolute but depends on the path taken through space-time. If one twin travels at high speed while the other remains on Earth, the travelling twin will age slower, returning to find their sibling much older. This is not a paradox but a real consequence of relativity. Time passes at different rates for different paths through space-time. The travelling twin experiences less time because their path through space-time is shorter in the time dimension, even though it's longer in space. This shows that time is not a universal flow affecting everyone equally, but a dimension that can be traversed at different rates depending on motion. The effect is real, measured, confirmed countless times, yet it remains counterintuitive, challenging our deep intuition that time passes the same for everyone. The twin paradox reveals that time is woven into space-time's geometry, with different paths having different durations, different amounts of time elapsed, showing that time is relative, flexible, dependent on how you move through the universe, not absolute but contingent on your trajectory through space-time's four-dimensional landscape. Time might be cyclic on smaller scales, with quantum systems repeating their states periodically. This phenomenon, called quantum recurrence, suggests that isolated quantum systems will eventually return to their initial state after a sufficiently long time, called the Poincaré recurrence time. For small systems, this time might be short, but for large systems like the universe, it would be unimaginably long, far exceeding the current age of the universe. If true, then time is cyclic in a quantum sense, with all systems eventually repeating, returning to previous states, creating a kind of eternal return at the quantum level. The theory is a consequence of quantum mechanics' unitary evolution, which preserves information and ensures that states cannot be truly lost. Everything that happens will eventually happen again, given enough time, with the universe cycling through all possible configurations. This quantum cyclicity suggests that time might be circular at a deep level, with the end eventually leading back to the beginning, though the timescales involved are so vast that the cycles would be imperceptible, stretching across eons beyond imagining, time repeating but on scales too large to observe. The psychological present might expand or contract depending on attention and engagement. When we're bored, time seems to drag, with the present moment feeling extended, while when we're engaged, time flies, with the present seeming to shrink. This suggests that the duration of the psychological present is not fixed but depends on how much attention we're paying and how engaged we are with our experience. The brain might allocate more or less time to the present depending on the situation, creating a flexible now that expands when we need to process complex information and contracts when we're on autopilot. If true, then the present moment is not a fixed duration but a variable window, adjusted by consciousness to match the demands of the situation. Time's subjective texture would be under our control to some extent, with attention and engagement allowing us to stretch or compress the present, making moments last longer or pass more quickly. This would explain why time seems so elastic, why some experiences feel timeless while others rush by, why the present can feel like a brief instant or an extended duration, depending on how we inhabit it, how fully we're present to our experience. Causal loops might be possible in certain space-time geometries, allowing events to cause themselves. If space-time curves back on itself, creating closed time-like curves, then an event could be its own cause, with no beginning to the causal chain. This creates strange possibilities. You could travel back in time and cause the events that led to your time travel, creating a loop with no origin. The mathematics of general relativity allow such loops, but whether they exist in our universe remains unknown. If they do exist, they would require exotic forms of matter or energy that we've never observed, suggesting that nature might forbid them through mechanisms we don't yet understand. Causal loops challenge our deepest intuitions about causation, suggesting that effects don't always need causes, that some events might simply exist in loops, causing themselves, with no beginning or end to the causal chain. The possibility remains open, tantalizing, suggesting that time might be even stranger than we imagine, capable of loops and tangles that violate our linear understanding of cause and effect, creating a universe where some events simply are, existing in eternal causal circles with no origin and no end. The far future might see the emergence of new forms of time as the universe evolves. As the universe expands and cools, the nature of time might change, with different eras having different temporal properties. In the current era, time is defined by stellar evolution, galactic motion, and cosmic expansion. In the far future, after stars have burned out, time might be defined by black hole evaporation, a much slower process. Even farther in the future, after black holes have evaporated, time might be defined by quantum fluctuations, incredibly rare events separated by vast spans of emptiness. Each era would have its own characteristic timescale, its own rhythm, its own pace of change. Time would not be uniform throughout cosmic history, but would evolve, changing character as the universe ages. This suggests that time is not a fixed framework, but a dynamic feature of the universe, shaped by the physical processes occurring at each epoch. Understanding time might require understanding the universe's evolution. With time's nature changing as the cosmos transforms, each era experiencing time differently, each epoch having its own temporal signature, time itself evolving as the universe moves from birth to death, from the Big Bang to the heat death, from rapid change to eternal stillness. If you've drifted in and out, that's perfect. These theories are companions, keeping you company as you drift, asking nothing, demanding nothing, just offering gentle wonder. Time's beginning might be unknowable, hidden behind the Planck epoch where quantum effects erase all information. Even if time had a beginning, we might never be able to determine what happened at that moment, because the conditions were so extreme that our current theories break down. The Big Bang might be a boundary beyond which we cannot see, not because nothing existed before, but because the physics of that era is so different from anything we can currently understand that it remains forever mysterious. This would mean that the question of time's origin might be unanswerable, not because we lack sufficient data, but because the nature of reality at that moment is fundamentally inaccessible to our theories. The beginning of time would remain a mystery, not from ignorance, but from the limits of knowledge itself, with the Planck epoch serving as a cosmic horizon beyond which we cannot peer. This suggests that some questions might have no answers, not because the answers don't exist, but because they're hidden behind boundaries we cannot cross, with time's origin forever obscured by the quantum foam of the universe's first moment. The multiverse might have a meta-time in which different universes exist at different moments. If the multiverse is real, there might be a higher-level time dimension in which our universe is just one moment, with other universes existing at different meta-times. This meta-time would be distinct from the time within each universe, representing a higher dimensional temporal structure that organizes the multiverse itself. In this view, our universe's entire history, from Big Bang to heat death, would be just one instant in meta-time, with other universes having their own instance, some before ours, some after, some simultaneous. This would create a hierarchy of times, with time within universes and time between universes, each level having its own flow, its own arrow, its own structure. The theory is highly speculative, part of attempts to understand the multiverse's structure, but it suggests that time might exist at multiple levels, with our familiar time being just one layer in a more complex temporal architecture. Metatime would organize the multiverse the way time organizes events within our universe, creating a cosmic structure of nested times, each level flowing at its own pace. Consciousness might experience time differently during dreams, with dream time not matching clock time. Studies suggest that time in dreams can be compressed or expanded, with experiences that seem to last hours, occurring in minutes of real time. This shows that the brain can create temporal experiences independent of physical time, generating its own sense of duration that doesn't correspond to external clocks. If consciousness can create its own time in dreams, perhaps it does so in waking life as well, with our experience of time being a construction rather than a direct perception. The brain might be constantly creating temporal experience, using external time as a guide but not being strictly bound by it, allowing subjective time to stretch or compress depending on mental state. Dreams reveal that time is more psychological than we usually assume, with consciousness capable of generating temporal experiences that have their own internal consistency but don't match external reality. This suggests that the time we experience is a mental phenomenon, created by the brain, not directly perceived from the external world, with consciousness painting time onto experience, adding duration and succession to a reality that might not inherently have them. The concept of the present might be different for different species, with each organism experiencing a different duration of now. Species with faster neural processing might experience a longer present moment, perceiving more detail in each instant, while species with slower processing might experience a briefer present, missing details that others see. This would mean that different organisms literally inhabit different temporal worlds, with each species living in its own now, its own present, its own flow of time. A fly might experience time in slow motion compared to us, seeing our movements as sluggish and predictable, while a tree might experience time in fast forward, with seasons passing like days. If true, then the present moment is not a universal feature, but depends on biology, with each species experiencing time at a rate determined by its neural architecture. Time would be relative not just to motion and gravity, but to biology, with consciousness creating different presents for different organisms, each one valid, each one real, each one defining its own temporal world, time itself becoming species-specific, biological, dependent on the particular mechanisms of perception and cognition that each organism uses to navigate reality. Time might be fundamentally quantum, with the classical time we experience emerging from quantum processes. At the deepest level, time might be described by quantum mechanics, with states evolving according to the Schrödinger equation, creating superpositions of different times. Classical time, the definite flowing time we experience, would emerge from this quantum time through decoherence, the process by which quantum superpositions collapse into classical definiteness. This would mean that time at the fundamental level is probabilistic and uncertain, with multiple possible times existing simultaneously in superposition, and only at larger scales does time become definite and classical. If true, then our experience of time is an emergent phenomenon, arising from quantum processes but not present at the deepest level. Time would be quantum at small scales and classical at large scales, with the transition between them occurring through decoherence. This theory attempts to reconcile quantum mechanics with our experience of time, suggesting that time's flow, its definiteness, its arrow, all emerge from quantum processes, with the quantum world being timeless or having a very different kind of time, and only our macroscopic world experiencing time as we know it. The expansion of the universe might create time, with time flowing faster as space expands more rapidly. Some theories link time's passage to cosmic expansion, suggesting that time is not independent of space but emerges from spatial expansion. In this view, time would flow differently in different epochs of cosmic history, faster during inflation when space expanded exponentially, slower during the matter-dominated era when expansion was more gradual. If the universe's expansion is accelerating as observations suggest, then time might be flowing faster now than it did in the past, with each moment slightly longer than the previous one. This would mean that time is not constant but evolving, changing as the universe expands, with time's pace linked to space's growth. The theory is speculative but offers a vision of time as deeply connected to cosmology, with time's flow determined by the universe's expansion, both emerging from the same fundamental processes. Understanding time would require understanding cosmic expansion, and the history of time would mirror the history of space, both unfolding together in the universe's evolution from Big Bang to heat death. The arrow of time might be an illusion created by our position in the universe's evolution. If we lived in a contracting universe, we might experience time flowing in the opposite direction, with entropy decreasing and effects preceding causes, but it would seem normal to us because our psychological arrow would align with the thermodynamic arrow. This suggests that time's direction is not absolute but depends on context, with the arrow we experience being a consequence of our particular cosmic era. In the far future, after the universe has reached maximum entropy, there might be no arrow at all, with time becoming directionless, neither forward nor backward, just a dimension without flow. The arrow of time would be a temporary feature, present only during the universe's journey from low entropy to high entropy, absent before and after. This theory suggests that time's flow is not fundamental, but emergent, arising from entropy gradients and disappearing when those gradients vanish. Time would have an arrow only in certain epochs, in certain contexts, with the direction determined by whether entropy is increasing or decreasing, and the flow itself present only when change is possible, absent in equilibrium states where nothing happens and time loses its direction. Quantum tunneling might allow particles to violate causality on microscopic scales, with effects appearing before causes. In quantum mechanics, particles can tunnel through barriers they shouldn't be able to cross, appearing on the other side without having traversed the space between. Some interpretations suggest that this process is instantaneous, or even backward in time, with the particle arriving before it left. If true, then causality is violated at the quantum level, with time's arrow becoming fuzzy and uncertain. Particles might move backward through time briefly, creating tiny causal loops that average out to normal forward causation at larger scales. This would mean that time's direction is only statistical, emerging from quantum processes that individually might violate it, but collectively create the arrow we observe. The theory remains controversial, with physicists debating whether quantum tunneling truly involves backward time travel or whether it can be explained without violating causality. But it suggests that time at the quantum level might be very different from time at our scale, with the arrow of time emerging from quantum chaos rather than being fundamental. Time's direction, a large-scale phenomenon that breaks down at small scales, where causation becomes uncertain and time itself becomes probabilistic. The experience of time might be fundamentally different for quantum systems, which exist in superpositions of different times. A quantum particle might not have a definite time until measured, existing in a superposition of having decayed at different times, all simultaneously. This would mean that time at the quantum level is not definite but probabilistic, with particles experiencing multiple times at once until observation forces them to choose one. If true, then time is not a universal framework even at the microscopic level, but depends on measurement and observation. Quantum systems would inhabit a strange temporal realm where past, present, and future blur together, with definite times emerging only through interaction with the classical world. This suggests that time is not fundamental, but emergent, arising from quantum processes through decoherence and measurement. The quantum world might be timeless in a sense, with time emerging only when quantum systems interact with larger classical systems. Understanding time might require understanding quantum mechanics, and the nature of time might be revealed by studying how quantum superpositions collapse into classical definiteness, how timeless quantum states evolve into the flowing time we experience. The concept of duration might be different from the concept of time, with duration being psychological and time being physical. Duration is how long something feels like it lasts, while time is the objective measure of how long it actually lasts. These can diverge dramatically. A boring hour feels much longer than an exciting hour, even though both last the same amount of time. This distinction suggests that we experience duration, not time, with consciousness creating the sense of how long things last independent of objective time. Duration would be a mental phenomenon constructed by the brain from memory, attention, and engagement, while time would be a physical dimension independent of consciousness. If true, then our experience of time passing is really an experience of duration, of psychological time, which can stretch or compress depending on mental state. Time itself would be external, objective, flowing at a constant rate, while duration would be internal, subjective, varying with experience. Understanding how we experience time would require understanding both time and duration, both the objective and the subjective, both the physical and the psychological, recognizing that what we call time is really two things: the external flow of moments and the internal experience of their passage. We're near the end now. Let the final theories wash over you like gentle waves, carrying you deeper into rest, into calm, into the soft embrace of sleep. Time might be the dimension along which information propagates, defining time's direction by the flow of information. In this view, the arrow of time points in the direction of increasing information, with the past being the direction from which information comes, and the future being the direction toward which information flows. This would link time deeply with information theory, suggesting that understanding time requires understanding information. If true, then time is not independent of information but defined by it, with time's flow being the flow of information through the universe. The past is fixed because information about it has already propagated, while the future is open because information about it hasn't yet been created. This theory connects time with causation, with knowledge, with memory, all of which involve information flow. Time would be the dimension of information, the direction in which knowledge propagates, the arrow along which cause leads to effect. Understanding time would require understanding information, and the nature of time might be revealed by studying how information moves through the universe, how it's created and destroyed, how it flows from past to future, carrying causation and knowledge and memory in its wake. The psychological arrow of time might be independent of the thermodynamic arrow, with consciousness creating its own temporal direction. While entropy increases from past to future, creating the thermodynamic arrow, consciousness might have its own arrow, defined by memory and anticipation rather than by entropy. If these arrows could diverge, we might experience time flowing in one direction while entropy increased in another, creating a strange disconnect between subjective and objective time. The theory is speculative, but it suggests that consciousness might not be entirely bound by thermodynamics, that the mind might have its own temporal structure independent of the physical universe. If true, then the flow of time we experience might not be determined by entropy, but by the structure of consciousness itself, with memory and anticipation creating a psychological arrow that usually aligns with the thermodynamic arrow, but might not have to. Time would be both physical and mental, both objective and subjective, both thermodynamic and psychological, with consciousness adding its own temporal dimension to the physical universe's time, creating a layered temporal structure where multiple arrows coexist, usually aligned but potentially divergent. Time might be an emergent property of quantum entanglement networks, with time arising from the pattern of correlations. Some theories propose that space-time emerges from entanglement, with the geometry of space and the flow of time both arising from how quantum systems are correlated. In this view, time would not be fundamental, but would emerge from the structure of quantum entanglement, with time's flow representing the evolution of entanglement patterns. If true, then understanding time requires understanding entanglement, and the nature of time might be revealed by studying quantum correlations. Time would be woven from quantum threads, a tapestry of entanglement that creates the experience of duration and succession. This theory is highly speculative, part of cutting-edge research in quantum gravity, but it offers a radical vision of time as emergent from quantum information, not fundamental but arising from deeper structures. Time would be a large-scale phenomenon, valid at our scale but breaking down at the quantum level, where reality is described by timeless entanglement patterns. The flow of time would be the evolution of these patterns, the changing structure of quantum correlations, the dynamic dance of entanglement creating the experience of moments following one another in the endless flow we call time. The universe might be a single, eternal moment experienced from countless different perspectives. This philosophical view suggests that all of time exists simultaneously, with the flow of time being an illusion created by consciousness moving through a static four-dimensional structure. The universe doesn't evolve or change. It simply is, complete and eternal, containing all moments in a single timeless reality. What we experience as time passing is just our consciousness moving through this eternal structure, like a reader moving through a book, with all pages equally real even though we read them one at a time. If true, then nothing ever really happens, in the sense of coming into being or passing away. Everything always exists, eternally present in the four-dimensional block, with consciousness creating the illusion of flow by experiencing one moment at a time. This view dissolves time into space, showing them as aspects of a unified whole, space-time, which doesn't flow or change but simply is, eternal and complete, containing all of history and all of future in a single timeless now, with consciousness creating the experience of flow by moving through this static structure, adding the sensation of passage to a reality that is forever still. Time might end not with a bang but with a whimper, gradually losing meaning as the universe approaches maximum entropy. In the far future, after all stars have burned out and all black holes have evaporated, change will become increasingly rare, with vast stretches of time passing between events. Time will still exist, but it will be almost empty, almost meaningless, with nothing happening for eons. Eventually, the universe will reach a state of perfect equilibrium, where no energy flows, no work can be done, and nothing changes. In this heat death, time might continue to exist as a dimension, but it would have no content, no events, no succession of moments. The universe would exist in an eternal unchanging state, neither past nor future, just an endless present with no flow, no duration, no meaning. Time would fade into irrelevance, not destroyed, but emptied, a dimension that continues to exist but contains nothing. This vision of time's end suggests that time might not end dramatically but gradually, slowly losing significance as the universe ages, eventually becoming a meaningless dimension in a dead universe, a coordinate without content, a flow without events, an arrow without direction, time itself fading into the eternal stillness of maximum entropy. The present moment might be the only thing that truly exists, with past and future being mental constructs. This presentist view suggests that the past no longer exists and the future doesn't yet exist, leaving only the present as real. Memories are present traces of past events, not the events themselves, and anticipations are present mental states about possible futures, not the futures themselves. If true, then time is not a dimension containing past, present, and future, but a process of becoming, with reality constantly changing, each moment replacing the previous one, the present being the only thing that is. The past would be gone, truly cease to exist, and the future would be genuinely open, not yet real. This view makes time fundamental and change real. with the universe constantly becoming, constantly transforming, never static. The present moment would be the boundary between what was and what will be, the knife edge of existence, the only time that is. This theory challenges the block universe view, suggesting that time is not a dimension we move through, but a process of transformation, with only the present being real, the past and future being abstractions, useful concepts but not existing realities, leaving only the eternal now, constantly changing, constantly new, the only moment that is. And so, our quiet journey through cosmic time comes to a gentle close. We've travelled far tonight, from the flowing river of moments to the possibility of eternal cycles, from time's arrow pointing always forward to the strange loops where past and future intertwine. The theories behind us now, like stars fading into dawn, each one a question about duration, about succession, about the mysterious dimension through which we all move, moment by moment, from birth to death, from beginning to whatever comes after. Some theories offered answers, others only deeper questions. Some felt solid, grounded in experiments and observations, while others shimmered like mirages, beautiful possibilities that might never be confirmed or denied. But all of them carried a piece of humanity's endless curiosity, our refusal to accept time at face value, our need to understand why moments follow one another, why we remember yesterday but not tomorrow, why time flows in only one direction. These theories, some ancient and some born yesterday, represent our attempts to understand the most fundamental feature of existence, the dimension in which we live our lives, the flow that carries us from past to future, from what was to what will be. Theories are strange things, aren't they? They're not quite facts, not quite fantasies. They live in the space between what we know and what we imagine, between observation and speculation, between certainty and wonder. They're humanity's way of reaching toward truth with imperfect hands, building bridges across chasms of ignorance, trying to understand mysteries that might be too deep for any answer. Some theories will be proven right, confirmed by experiments and observations, becoming part of our established understanding. Others will fade away, replaced by better theories, better explanations, better ways of thinking about time and existence. But the reaching itself, the wondering, the questioning, never stops. We keep asking, keep theorizing, keep trying to understand, because that's what consciousness does, what minds do, what it means to be human in a universe full of mysteries. If your eyes are already heavy, that's just fine, perfect even. Let the last traces of cosmic time fade behind your thoughts, becoming less distinct, less important, like memories of dreams dissolving in morning light. Let your breath carry you softly into rest, each exhale releasing a little more tension, a little more need to understand, each inhale drawing you deeper into calm, into peace, into the gentle embrace of sleep. There's still so much more to discover about time, endless theories waiting, countless questions unanswered, mysteries that might never be solved. But for now, you've learned enough. You've wondered enough. You've travelled far through theories and possibilities, through strange loops and eternal cycles, and time can wait until morning, patient and unchanging, ready whenever you return. You don't need to remember any of this, not the theories, not the details, not even the questions themselves. They were never meant to be memorized, only experienced, like watching clouds drift across the sky, like listening to rain on a window, like feeling the sun warm your face. What matters is not what you retain, but how you felt while listening. The gentle stimulation of curiosity, the soft pleasure of learning, the quiet comfort of questions asked in darkness. That's enough. That's everything. The theories were companions for your evening, voices in the dark keeping you company as you drifted towards sleep, asking nothing, demanding nothing, just offering wonder and possibility, and the strange beauty of mysteries that might never be solved. Notice how your body has grown heavier as we've talked, how your muscles have softened, how even the weight of your thoughts has decreased. This is the natural rhythm of rest, the way consciousness gradually releases its grip, letting you drift into sleep, into dreams, into the quiet darkness where time itself seems to stop. You don't need to force it. You don't need to try. Just allow it, the way you'd allow yourself to float in calm water, trusting the water to hold you, trusting the darkness to be safe, trusting that sleep will come when it's ready, gentle and inevitable as dawn. There's nothing you need to do now. No theories to understand, no questions to answer, no puzzles to solve. Just the calm certainty that mystery itself is a kind of lullaby, one that will carry you into sleep. Time will continue flowing whether you're awake or asleep, whether you understand it or not, patient and eternal, carrying you through the night into tomorrow. So let go. Let your mind wander where it will, through dreams or darkness, through memories or nothing at all, through the strange landscapes of sleep where time becomes fluid and strange. Thank you for spending this time with me, for letting me guide you through these theories, these questions, these mysteries about time and existence and the flow of moments. Thank you for your curiosity, for your willingness to wonder, for choosing to end your day with learning rather than emptiness, with questions rather than answers, with mystery rather than certainty. It means something, this choice you've made. It says something about who you are, someone who seeks understanding even in the quiet moments before sleep, someone who finds peace in wondering, someone who can rest while still being curious, still being open to possibility. And I'm grateful to be part of your evening, part of your routine, part of the quiet ritual that carries you from waking into sleep, from day into night, from consciousness into dreams. You're not alone in this. Right now, all across the world, others are listening too, drifting through these same theories, wondering these same questions about time and existence. Some are ahead of you, already deep in dreams, already lost in sleep's embrace. Others are just beginning, just settling in, just starting their journey through these theories. But you're all connected by this shared experience, this common journey through mystery and wonder, this search for understanding in the moments before sleep. A quiet community of curious minds seeking rest and knowledge in the same breath, finding peace in questions that have no answers, comfort in mysteries that might never be solved, each one drifting through the same theories, the same questions, the same gentle wonder about time and its nature. Imagine yourself now, floating through the theories we've explored, passing by them as if through constellations in the night. Questions above, questions below, a galaxy of wonder all around you, each theory a star in the darkness, each question a point of light. And you are at the quiet center, resting in the knowledge that mystery is not something to fear but something to embrace, something beautiful and peaceful, that not knowing is not failure but invitation, an opening into wonder, a door into possibility, that the universe keeps secrets not to frustrate us but to keep us curious, to keep us reaching, to keep us human in our endless questioning. Let that thought comfort you. Let it wrap around you like a blanket woven from starlight and uncertainty, soft and strange and somehow perfect, exactly what you need. The theories we've explored tonight are just whispers in an infinite conversation, questions asked across time, mysteries that connect us all, past and present and future, everyone who has ever wondered about time and its nature, everyone who has looked at the flow of moments and asked why, asked how, asked what it means. You're part of that conversation now, part of that endless wondering, part of humanity's long attempt to understand the dimension in which we live. And that's beautiful, that connection across time, across space, across all the moments that separate us, united by wonder, by curiosity, by the simple act of asking questions about existence. There's nothing left to do now. No answers to chase, no puzzles to solve, no theories to understand. Just the calm certainty that mystery itself is a kind of lullaby, one that will carry you into sleep, into dreams, into the quiet darkness where time becomes strange and fluid. So let go. Let your mind wander where it will, through dreams or darkness, through memories or nothing at all. Let your consciousness dim like a sunset, gradually, naturally, beautifully, colours fading into twilight, twilight fading into night, night fading into the deep darkness of sleep. And know that when you wake, the theories will still be here, the questions will still wait, and time will still be strange and wonderful, still mysterious, still flowing from past to future, still carrying you through existence, moment by moment, breath by breath. I hope you sleep well and dream softly. May your rest be deep, your dreams be gentle, and your tomorrow be bright. May you wake refreshed, renewed, ready for whatever time brings. Thank you for being here, for listening, for wondering, for drifting through these theories with me. Good night.